Hi everyone, thank you so much for joining us today for our CMM Programming webinar. My name is Karina and I am the Digital Marketing Coordinator here at Swoosh Technologies and Solutions. I'll be your host for this event along with John Vincent, one of our application engineers who specializes in NX CAM. Just a reminder, this webinar will be recorded and sent out to all registrants upon the completion of the event, so stand by if you're looking to save that for future reference. We will also be sure to post it on our website, swooshtech.com, as well as our YouTube channel. So for those of you who have followed us for quite some time, it's of course great to have you back, and if you are new here, we want to provide you with a warm welcome. But before we get started, I would love to give a brief overview of Swoosh Technologies and Solutions if you're not currently familiar with what we do. Swoosh Technologies is an award-winning Siemens PLM Platinum partner that was first established in 2005 with over 16 years of industry knowledge. And our main goal is to provide beneficial solutions, technical support, and process-based training. With plentiful resources and hands-on guidance from our experts, we change the way that designers and manufacturers learn and leverage PLM tools, and ultimately that's just our goal for everyone who takes part in what we do. So today, John Vincent will be happy to answer any questions you may have, so be sure to send us any questions within the chat section of this webinar. And in the meantime, I will be here to monitor any of those, and we will address them at the end of this presentation. And with that in mind, I think we can go ahead and get started with section 1 of 2 for today's demo.
Hello everyone, my name is John Vincent and I'm from Swoosh Technologies. Today we're going to be discussing NX CMM inspection. And within the NX CMM inspection module, we're going to really be looking at how to go ahead and program your CMMs offline in an associative manner inside of NX software. So before we get hands-on and looking at how the module actually works, we just want to talk a little bit about some of the trends that are going on in industry, different hardware processes involved in organizations on a day-to-day basis. We'll take a look at some example workflows from that you might be used to using within your organizations. And then, of course, we'll get into actually programming some inspection toolpaths inside of NX, utilizing the full tool set of either manually programming or using automation based on PMI information that could be embedded in your models. So here we are looking at a little bit of the trends inside of the inspection industry. For many years we simply had tactile probing on CMM machines. And while that's still a very valid approach and commonly used, there's also a number of new technologies that can be utilized. Laser scanning is gaining in popularity. But additionally, on your more traditional CMM measurements, we can start using high-speed contact scanning, where we're actually sweeping surfaces or planar regions, things like that. And we can do multi-axis scanning. This will really enable us to measure more features with greater accuracy while utilizing the multi-axis functionality of CMMs. Additionally, there's new machine types, not just your traditional CMMs that are moving a X, Y, and Z coordinate. We have some new comparator type machines, very high speed machines for production type work where we're going to be inspecting lots of parts. So it's really a different approach to measuring parts. But all these things we can work with inside of NX. So in addition to hardware advances, one thing that is becoming commonplace is the use of always wanted to inspect to your CAD geometry as opposed to having a two-dimensional print and using that data. More and more we want to measure based on the 3D model and additionally use 3D annotations, so PMI information. Now this data can be used as kind of traditional tolerancing or using geometric dimensioning and tolerancing standards. And we want to be able to automate a lot of this functionality. So when we're programming inside of NX, we have a lot of embedded features that we can go ahead and automatically recognize features. So we're very quickly able to find features, program those features for our inspection paths. Really reduces a lot of the repetitive nature involved in inspecting things like bold patterns or just any repetitive features. And lastly, we want to really be able to close that loop, the entire process loop. Traditionally, at the front of the process, we're designing a part, dimensioning it, applying tolerances, passing that over to the manufacturing department where a part gets produced, hopefully abiding by all those tolerances. And then we go to quality to verify. Well, now we have the ability to go ahead and pass all this information from one process to the next, but additionally we can feed this information back. So for instance, we can, after inspecting our parts on a CMM, we can feed back the results into NX, and we can do things like overlays and really understanding where there may be some discrepancies from the digital world to the physical world, and help alleviate those. So again, here we have a few different workflows laid out that you may be familiar with or use them or some manner of them or combination of them in your current organizations. So first, just to discuss quickly about what we consider programming online. Essentially, this means that you are going to program your CMM tool paths on the CMM machine with the physical part. So you're actually going to go through, move the machine around, kind of teach all the positions of your part or your features specific to this part. So there's some downsides to that. One, you have to have the physical workpiece. So you have to go through the manufacturing process, set everything up on your CMM, and then go ahead and start creating your program. Now, some of the other issues that you'll encounter here is, well, what do you do with your piece of CNC equipment or however you're producing this part? Do you shut it down and wait for the inspection results? Do you set up another job and then you're kind of going back and forth? There's just some inherent process issues here. One way to alleviate that is to manually code your inspection programs just based upon 2D drawings. So going through and actually laying out where all these features should be, and then again, you'll load up your physical part, start running it, maybe do a little debugging based on that physical piece. Or a third option is to program offline. So the primary way, or traditional way to program offline is using some proprietary software to your specific CMM piece of equipment. And this works. This is good. You're able to either use two-dimensional prints or program directly on your 3D models without having to have that physical piece and without tying up other equipment. The downside to this method is if you have multiple types of equipment, so maybe you have CMMs from two different manufacturers or multiple manufacturers, and maybe even different software on for these CMMs, that can become an issue that you can't transfer data from one piece of equipment to the next. So our solution working inside of NX with NX Inspect is going to really alleviate all of these issues. We're gonna show you how we can measure off of our part geometry. We can really utilize PMI data to not only gather all the information for what features need to be inspected and how they need to be inspected and toleranced, but it's really going to drive how we program our machine. And lastly, we don't have this limitation of being tied to a specific piece of equipment. We can utilize any equipment we want within our environment and post out our information to particular CMMs. Okay, so we're going to go ahead and start looking at some of the capability within the NX module. So I started speaking to some of the benefits that we'll see here. We're going to be able to have very high quality programs created with very little effort. And we're going to do that by utilizing our 3D models with embedded product manufacturing information, our PMI data. When we do that, we can go ahead and automatically link to all of our PMI data. That'll create our features, our tolerances, and really assign how we're going to measure these features on the physical piece of equipment. Additionally, this is all going to be associative. So if there's any design changes in the process, we don't have to go through and really reprogram. We'll have to just regenerate our tool path, or I should say inspection path, and post the program out to the machine again, and we're updated to the latest and greatest model. And if you're using NX CAM for your programming and utilizing our simulation, it's important to note that our inspection module works very, very much in the same manner. We're able to go ahead and set up any of our, or create our setups inside of NX, so we can utilize and show our fixture requirements, how we're going to hold the workpiece, where we're going to be fixtured on our parts, so we can ensure no over travel issues, make sure that we can reach all of the features that we're going to be measuring with the current stylus that we have called out in our program. So we're really operating in the physical context of the machine. So I spoke a lot about using PMI data. That's a great way to really reduce time in how you program. But we don't always have that. Maybe we work on with customer data, and some customers don't provide PMI information. They still give you a two-dimensional print. That's okay. We have a full tool set to go through and specify our various features that we want to inspect. How do we want to apply tolerances, whether it's strictly plus minus tolerances for positioning or size, or going through and using any of our GD&T measurements. And again, I want to stress that regardless of what method we work with here, all of these features and programs are going to be associative. So again, if we get a change from the customer, they provide us a new model, we just import the new model, reassociate that link, and we'll be able to go ahead and update all of our CMM programs, really closing that end-to-end process. And lastly, the ability for us to go ahead and analyze the data that we get from our CMM and visualize what that looks like inside of NX is a great benefit. So we can go ahead and import the data from our CMM, and we can really view any tolerances that are out of specification. We can view what those deviations are, how large the deviations are, and then we can go back to our design side or CAM side of the software and really do a deep dive and understand exactly where we're getting any kind of measurement deviations or size deviations in our process, and go ahead and resolve those. So I'm going to jump into NX now and just do a little bit of a live demonstration showing some of this functionality. So to start off, in this case, I am going to work with a part file that I've already started, and we have a program existing. So in this case, we have some various features created already. We have some inspection paths already existing, as well as tolerancing for the existing features. So just to start off, we can see we have embedded PMI on this part model, but I'm not going to utilize any of that. I just want to go ahead and measure a feature and program a feature manually here. So the first thing I'm going to do is create a feature. So in order to do this, I'm going to specify a new cylinder. I can just launch a dialog and select a piece of geometry, in this case this outside diameter of my workpiece. And inside my dialog, I'm simply going to go through, once I've selected that piece of geometry, I need to specify, is this an inner diameter or an outer diameter? In our case, it is an outer diameter. And you can see NX already interrogated the model and found what the actual model diameter is here. So I'll say OK and accept this feature. Maybe I'll rename it first. So our feature name is going to be cylinder2-demo. And we can see that it's been generated, or it's been created. I can go ahead and generate that feature so we have all the information ready to go. And now I'll apply a couple tolerances to this feature. In this case, you can see I've already have my cylinder 2 feature selected, and I'll go ahead and select a diameter tolerance feature. So again, since I've already pre-selected my cylinder 2 demo feature, it inherited the nominal diameter, and I can assign any tolerances I need, upper and lower tolerance. So this would be the process you would typically go through if you had a two-dimensional print. Create your feature, create your tolerance, and we can then create inspection paths from that data. So I'll go ahead and leave these default values for now, and I'll say OK. And we can see the tolerance has been created. But maybe I want to add an additional tolerance. In this case, I want to also measure circularity. In this case, I want to assign a tolerance of, let's do 10 microns. Again, my feature was already pre-selected for me, and I will go ahead and just apply those tolerances. And I like to generate them. All right, so we have those two pieces of information, our feature and our tolerances for that feature. So you could go through and do this for all of the features on your part, and then create inspection toolpaths at the end. Or for our instance, I'll just create the one inspection path right now. So again, I have my cylinder 2 demo feature highlighted, and I'll go ahead and create an inspection path. So out of the box, there's many methods for how we can measure things. So we can, different types of geometry that we want to use. So in this case, I'm going to use this inspect cylinder. This method was already selected for me automatically because the feature type was known to NX. Now I need to add some sub-operations. These are the actual motions of our touch probe. So here, this inspection dialog is going to go ahead and launch. And this is where I can specify what type of motion do I want. So you can see we can measure, individual points. We can program safety moves, point sets if you want to have a series of points on a piece of geometry. Different scanning tool paths. We have a lot of options for how you can program your part. NX, of course, has a lot of rules built in, so it knew that most likely my preferred method here would be to use this scan arc move type. So I'm going to come through and just change a few settings. Again, we have this feature that's it's a cylindrical feature, but we have some cutouts in it, so I want to change just my start and end points of our toolpath. In my case, I'm going to specify my inspection area, and I want to kind of do a little bit of a shift from the top of the cylinder and the bottom of the cylinder. So in this case, I'll just start changing some values a little bit. I'm going to offset, in this case, 8 millimeters from the start and 3 millimeters from the bottom. And now we can see we have 3 paths, and that's going to be this number of cross sections. We have 3 paths interpolating around our cylinder. So if I zoom back out now, I'll press OK to this dialog, and I'm actually going to run some machine code simulation. So interactively, NX will go ahead and run the post processor for this particular CMM machine, and now we can simulate what's going to happen here. So in this case, you can see we have a 5-axis scanning inspection path. So we're going to go ahead and sweep the diameter of this part. And you can see, again, doing this in 2 paths. So we're able to really visualize our tool path, or I should say inspection path, to verify that there's going to be no collisions, no over travels. We have all the reach that we need with the given stylus that we've programmed. And we can verify all the motions that the physical machine is going to move. So we're going to have a tool path that's ready to go when we send it out to our CMM machine.
All right, so we're going to go ahead and take a quick break, and once we are done, John will walk us through Section 2 of CMM Programming. In the meantime, I would love to take a moment and highlight some of the training opportunities that we offer here at Swoosh. If you go to swoosh.com and our website and visit the Training tab up here at the top, and you click on the classroom schedule, you can go see everything that we have to offer at this moment. So we have a lot of different classes to choose from, as you can see here at the top. We break it down into different sections: NX CAD, NX CAM, Team Center, and Solid Edge. So if you just keep scrolling, you'll go ahead and see all of the ones that we offer. Things like NX for experienced CAD users. If you keep scrolling, you'll see NX Drafting Essentials. Everything that you could think of, we have at your fingertips on our website. And if there's anything that you are interested in, you can, of course, always shoot us a message, shoot us an email. You can visit our contact tab on our website, and you can just ask us if there's anything that we can customize for you, if there's something that's not currently on there, and we can just let you know in a form back or an email back or a phone call back, whatever is the best form of contact for you. So go ahead and visit this after the presentation, and we would love to see what we can do for you. All right, so I think John is ready for Section 2 of today's CMM programming demo, so let's go ahead and jump into that. And please don't forget, you can ask any questions at any time within the comments section.
All right, so now we're going to start talking about automation of programming of your inspection paths. We started looking at some of the basic creation manually. So now we want to talk about, what will this automation give you? Really looking at utilizing the full process of embedding PMI data and driving your process from that data. So we routinely see reductions of up to 80% of our programming time when we use our feature creation, tolerance specification, path creation, and collision avoidance tools, automating all of these approaches. And again, this is how we achieve our very fast, repeatable CMM programs. And in the end, once this is set up, then we don't need to have a high level of expertise for every user. It's really the software that's driving the processes. So we are able to do this starting with this first functionality called Link to PMI. So Link to PMI enables us to create an associative link to all the PMI data that's embedded on a 3D model. Now again, this data can be native to NX, or it can be imported using like the Step 242 translator. You do maintain a little bit more data with a native NX file. So again, depending on your organization, where you're designing software, or I'm sorry, designing parts, or receiving parts from, models from. Maybe they come directly from your customer, and you'll work with a myriad of different origins. We're able to handle all these different scenarios. Your process might just be a little bit different of, what is the input, and then what are you going to be working on when you start working on your program. We can always author new PMI on any model if it's not embedded when we receive it from a customer. So again, this link to PMI, it is really defining everything automatically from your CAD geometry. It's grabbing all the tolerance information out of that PMI information, and it creates your features and methods all based upon your PMI data, and this is what drives your inspection paths. So again, if you're not familiar with PMI, there's certainly PMI standards out there for how to model or how to dimension your geometry within your 3D model. Again, this can be just dimensions with tolerances. You can specify datum, surfaces, target features, feature control frames, so on and so forth. Anything that you can do with GD and T type information or tolerancing information on a traditional 2D drawing, you can do with PMI. Additionally, PMI can be shown directly on your 3D model, and we can control the visibility through through things like filtering with our show hide commands, creating PMI data strictly in separate views, lots of ways to manage this information. And I don't want it to sound like everything has to be embedded on the 3D model. We can certainly still use PMI information and transfer it to your 2D drafting files if that's still a requirement within your organization. Certainly not a problem. And really, PMI as a whole, this is a topic that starts at the beginning of the process with the design process, and PMI can really then drive much more of the process. This can go through and help with manufacturing processes, management of how to route parts, how to, of course, inspect parts, then out to production. So PMI is an extremely valuable tool to use throughout the life cycle of a process. So we want to show some of the hands-on approach to automate the automation of some programming. So here we have a part. It has some various PMI information on here, pretty basic. It has some fit tolerances, some bidirectional tolerances for position of features, width of features, as well as we're calling out actually some surface finish requirements. So this is a part that we can use feature-based machining to go ahead and automatically program the part using some of this PMI data, and then we can use that same data once again on the inspection process to create our programs. So in this case, I'm just going to show creating from scratch a new inspection program. So I'm just going to accept this default Wenzel machine. And we'll go through, NX is going to go ahead and load this part file into my CMM environment. And from there, we can go ahead and look at what it takes to start programming. So the first thing I see is our part's not really oriented in a great location for our case here. So I'm going to go ahead and just move this part around a little bit. And in this case, I'll just slide our part over a little bit more towards the center of the table. And you could use normal assembly strategies, any of the tool sets inside of NX that you're already used to. All that's going to work in here. For sake of the demo here, I'm just going to go ahead and leave this part kind of floating in space here. But we could, of course, set up information, apply fixtures for this part, so on and so forth. All right, so now that we have this parts started here, we can see we just have two things. There's a program header and a basic alignment feature. So before I do anything else, the first thing I'm going to do is link to PMI. So there is PMI information embedded in this model. So I'll go ahead and select that. And I'm going to leave these options. Create paths for my inspection probe, for all the automatic options. Just let NX go ahead and make a decision on what's needed here. And I'll say OK to this dialog, and all that these PMI links are being created. And we can see here in our information window we have some feedback from the software. So in this case, it's telling me that the following PMI was not linked. These are those surface finish symbols. There's nothing that we're going to inspect with a CMM for surface finish. These PMI data were used for feature-based machining to specify things like our machining method, or speeds and feeds to achieve a certain finish. For inspection, we're going to be looking at a couple of these linear dimensions and a radial dimension that's on this part file already. So now we can see, if I expand our features, paths, and tolerances, all this data was already imported, and the features were created. Some inspection paths were additionally created here. You can see those are representing some probing lines, as well as all the tolerance information. Let me go ahead and open up any of these tolerances. So this nominal width, 44 millimeters, had a plus 0.2 minus a tenth tolerance. All that information automatically was created inside of our inspection program. So we have a few more tools that I want to touch on, but first I'm just going to go ahead and run the machine simulation as it was automatically created here. So let's go ahead and just play this. You'll see we're going to go ahead and grab our probe or stylus from our tool rack there, and we're going to be measuring features, moving around to different positions, and you can see here I have a limit a violation. That's okay. I'm just going to say continue till I am reset. You might notice, yeah, there's definitely some collisions going on there. Not what we want to see right now. Okay, so what we have here is we've done our first automated approach. We've just created our tool paths. So there's a few things we want to do now. The first option I'm going to choose is collision avoidance. And I'm just going to specify a safety plane. In this case, let's bring a plane up above our part. We'll go 30 millimeters and say OK. And OK. And NX is going to go ahead and analyze the tool paths or inspection paths and just change things a little bit. And so here we're getting feedback that it's telling me about transition points that were inserted, changes to our sensors or our measurement points. So if I run that machine simulation again, we'll see that, okay, we are now measuring things in a little bit different order. And okay, we're seeing some more limits here. Let's just go ahead and continue measuring some different features. And you can see how we're having a number of tool paths that were still doing some over travels. So maybe we want to go back and move our part a little bit. And we're going to say, okay, we know that we were limiting it out on Z. Let's go ahead and just bring our part up. Let's say we're going to raise it 100 millimeters via some different fixturing. And we can come back in and just go ahead and regenerate our inspection program. And I can run my collision avoidance again, just to verify that there's no issues. And here we're saying, okay, there was No collisions found for most of these paths. The second path had 2 collisions, and it's telling me that could not be resolved right now. And then let's go ahead and resequence these paths. We have the option to automatically resequence our paths based on different information here. We may want to prioritize that if we have tool changes. We want to probe everything with one stylus before we change out, so we're just not having those multiple tool changes. We can resequence by head angle changes and distance to path, all of these different options. So again, this is all automatic. We just pressed OK. And now we will go through and run that simulation one more time. And we're going through doing all of our probing. And we can see we're probing a lot of points. We'll take a look at how we can adjust that. That's built into our methods. Here you see we're having a y-axis limit. So again, I could go ahead and slide my part out of the way to fix that. These are those 2 collisions that could not be resolved. It's going to always limit out unless I move my part. And NX won't do that for us automatically. If you noticed, in here we're probing a lot of points. And we can do this at the individual operation level. We can modify this, or we can modify it at our inspection level. So in this case, I edited my inspection plane method, and we can see we're taking 8 points in both our U direction and V direction. So maybe that's too many. That's more than what we really need. And I'm going to change this down to, we'll say 3 and 3. You see all those paths went out of date, and I can simply regenerate them. And if we take a look at some of these tool paths now, we'll see that we're doing 3 paths across in one direction, and 3 points, I should say points, 3 points across in one direction, and 3 points in the perpendicular direction. So before we were doing 8 by 8, now we're doing 3 by 3. Very easy to change up the number of points or inspection criteria that you want. And it wasn't just for one operation. Because I did it at this method level, it made the same changes to multiple operations all at one time. Same likewise on these larger surfaces. We're all 3 by 3 here. Okay, so starting to talk about actually outputting information and the quality of the information that we're going to be giving to the CMM. It's important to realize that we are going to be working in the context of our CMM. So all those clearance issues that we just saw, we're able to very quickly verify the tool paths, or I should say inspection paths, move our workpiece around on our CMM table, maybe adjust the heights or orientations of our parts to ensure that we can go ahead and be comfortable with the fact that when we actually run this program, it's going to run all the way through the first time. So again, this is going to eliminate kind of your checking at the CMM itself. Verifying that, yeah, we have enough clearance. Oh, no, we're not going to reach a certain feature. We need to stop, reprogram, come up with new head angles. NX is going to do all that for you with these collision checking automation tools. And again, likewise, how we can quickly move things around, we can also switch from machine to machine very quickly. It's just a matter of replacing the CMM machine in your setup, and all the proper post-processors and kinematics of the machine are going to be inherited into your new environment. Likewise, you saw that collision avoidance. Great tool that by automatically NX is going to just create your tool paths. It's not really looking at head clearances and things like that. But once I have those tool inspection paths created, I go ahead and run that automated collision avoidance feature, and it's going to go ahead and detect any of these interferences, and it'll move the head out of the way, reorient to new index positions, and then go ahead and complete the measurements as needed. And what we're going to output is typically the most common, I should say, output is DMIS, but we can support any post processors, or I'm sorry, any CMM machines. We can have create post processors for any of them. There's many ways that many different types of CMMs out there, but largely DMIS based. But of course, there's other softwares like Calypso, so on and so forth. For Wenzel machines, they have their own package. Zeiss has some of their own stuff that can be Calypso or DMIS, or can run on both. It's really a very flexible tool that we can set it up to be exactly how you want to see it within your organization. So we're going to jump back and just do one more little demo here, showing a little bit different machine in this instance. I'm going to go through the same process. We're going to start with this link to PMI. Go ahead and let NX interrogate it, link all the PMI information, create our features, create our tolerances, and our inspections paths. So in this case, you can see all the PMI was linked successfully. We have our paths. Let me go ahead and just simulate this machine real quick. And we'll see, we're going to grab our tool and go ahead and start working on our simulation of our inspection paths. So we're running through, okay, we have some collisions. I could continue and keep watching this, but this is where I will go through that same process of doing my collision avoidance. In this case, we already have a safety plane specified, so I'll just say, okay, let NX do its thing, calculate this. All right, we see we have some transition points inserted in a few different operations. And I like to just go ahead and resequence my paths right away. Let's just let the software optimize things. And we'll simulate this inspection program. And you can see we're sweeping a number of bores, probing some planes. In this program here in a little bit, it'll actually sweep some different contours on our part all the way throughout this program. And there we go. We ended up with a collision-free program. Now I just want to show a little bit about the associativity. So briefly here, I'm just going to go back to my source model, the actual design part. And with synchronous modeling, I'm going to move a few features around here. So let's grab a couple of these holes. And let's just drag them around. Just move it a little bit. I'll say OK. And we can see that our part, the location of these features has been modified. Additionally, maybe I'll come in and I'll resize some faces here. Let me use my command finder. And I'm going to resize these four bores. They're at 11.25 millimeters right now. Let's go ahead and make it 12.25. And you can see our PMI updated right away as soon as we made these changes. And if we jump back to our inspection program, again, you'll see the 12.25 value has now been updated. The position has been updated. And in our inspection program, we'll go ahead and just regenerate these inspection paths. And we're ready to go ahead and simulate this again. And we can see that there we did some scanning. There we're interpolating those bores at the new location and new size. So very quickly we were able to modify our part geometry and update the downstream processes. This is the huge advantage of working in one integrated solution, enabling you to utilize an end-to-end closed-loop process. And speaking to the integrated process, here we are. this is what we just saw is the benefit. We have our CAD model. Likely we're driving our CAM programming from the CAD model, and then likewise our CMM programming, all coming from that same master source. So we go through and end up running our program on our CMM, and we can import our results files back into our NX inspection to go ahead and overlay the information on our model, so we can go ahead and do some analysis and look at what the results are. We can provide some feedback for design changes or manufacturing changes. And again, this process here, we're really doing two things. We're driving our CMM programming from that original design, and then on the production side of our software, we're running that information, the program, on our CMM, and again, importing back into NX if you want to go ahead and get that validation in your software. So again, our integrated approach here is really allowing us to have the entire scope of the project managed within one software. We're able to use all of our best practices. I can set up information for my manufacturing operations in the exact same manner that I can now do it for my CMM inspection process. Any changes that happen throughout the part life cycle will quickly enable you to update all the downstream processes by working via this master model approach. And lastly, just to speak to the ease of use, it's largely an automated program, so it's very easy for people to learn the application. There's not if it's an experienced NX person, you know how to go through, add parts to assemblies and move things around. Quite simple to go ahead and lay out your inspection programs. And we have a nice streamlined workflow from beginning to end. Starting with our CAD model all the way throughout CMM inspection. We have a great number of resources out of the box. So we have very common machines: Wenzel, Brown and Sharp. I'm trying to think, Mitutoyo, Zeiss. A lot of out of the box CMMs available. And if you have any others that you need, we can certainly work with you to build those machines, as well as all the different stylus that's available. Very easy to capture all your different stylus and the kinematics of how they move, how they rotate. There's a lot of dual rotary heads on CMM machines now. It's very easy to capture and reuse all this data. And lastly, we can certainly use any of our API, open API tools, journaling and knowledge fusion and other applications that we want to extend NX to create some custom features or custom processes. It's a very open system that will enable us to modify the behavior for your organization's specific needs. And with that, I think we've shown a good example of the introduction to CMM programming within NX, and I look forward to hearing any questions that you may have about this product. Thank you.
Okay, thank you so much for that presentation and demonstration, John. We're going to go ahead and take a look at some of the questions that we got in while you were presenting, and we will go ahead and compile them in an email that gets sent out after this webinar that will also include the answers from John himself, as well as the webinar recording from this event. If there were any questions that you weren't able to give us in the chat box during this time, you can of course go to our website, swooshtech.com, and we can certainly address those throughout the contact tab whenever you submit a form. I would just like to thank everyone again who joined us for this session today, and if you like what you saw, be sure to just keep an eye out for our upcoming webinars on the 2021 schedule. Right now we have 3 in the works: staged models, NX Mold Wizard, and NX Electrode Design. So those will be coming in the upcoming months, so just keep an eye out for those. Additionally, we are also bringing back in-person NX University, otherwise known as NXU, which includes a total of 8 cities that our team will be traveling to between October and November for hands-on NX group training. And if you would like to register for the event, just stand by and we will be sending you all email information for this shortly in the coming weeks. So I just hope everyone has a great rest of your week. Please just contact us either via my email, karina.mcglasson@swooshtech.com, or of course through our website through the contact tab. We would love to address any questions you may have, any insights, or any feedback that you have altogether. And again, I would just like to thank you for joining us for the CMM Programming webinar. Have a great week, everyone.